the subject of the talk of today is about Ammaia, which is a Roman town in Lusitania. So we're not so used to archaeological investigation there. So this is why it's quite interesting to speak about that today. But of course, we will not speak, and they will not speak only about the Roman town, but also about all the surrounding of this town, and especially the countryside all around. And this is probably one of the most important thing about this study. And of course, this study is about non-destructive methods, and I'm sure that they will not speak either the Wittelmann or Lievenverdonck. They will not only speak about geophysics, but certainly about other topics. So this is what we call, broadly speaking, a landscape study. It's a landscape study which is now finished and published. It began in 2001. And so I think it's quite an important milestone in the study of Roman territories in Europe. So I will not speak more about that because it's not so interesting. I will let the talk to both speakers. So I can introduce Lievenverdonck a little bit because I know him since quite a long time. David Tolman, unfortunately, I don't know him yet, but I know that you are also a postdoc from the Ghent University. So Verdonck is also for Ghent University. He has an education as a Doctor of Archaeology, PhD, in 2012. He's been working with Armin Schmidt about the high-resolution GPR prospection. And before, he has a long experience also in archaeology, but also, I should say, also a licentiate in law in 1997. And after that, he's got 2 PhD postdoctoral fellowship, both in Ghent with the team of Frank Vermeulen. And so he has a good experience also, of course, in different sites in Italy. But this is not the subject of today, but you can find some Frank Vermeulen explanation also online if you want, if you're interested. And I'm sure that Ankadan will tell us the different links about that. Lieven has also an experience in a private company, Eastern Atlas in Berlin. Most of you, I think, know about this company, and of course, he has some very good and numerous publication. I don't know exactly the number, but probably more than 60, if I remember properly. And recently, a very, very interesting paper, which has been worldwide known, I should say, all around the world in antiquity, about the Falerii Novi, which is quite interesting and, of course, interesting paper, but with a wide scope. That's all. I don't want to say much more about that, but now it's time for you to speak about that. And Davy, if you want, I don't have your bio, so I cannot introduce yourself as well as Lieven. But if you want to speak about a few minutes about your things you have done before, please.
Okay, thank you very much for the introduction. But I'm also a postdoc researcher at Ghent University, and I did my PhD actually on the site of Ammaia, and I mainly work on landscape archaeology and material studies, so the provenance of stone material. And this will be partly what I'll be talking about today. And my current postdoc project is on the provenance of marble, actually. So it's less related to landscape archaeology, but more to archaeometry, let's say. So today Lieven and I will be focusing or talking about the site of the Roman town of Ammaia, which is located in present-day Portugal. So at the site of Ammaia, from which you can see here a 3D reconstruction drawing. So the first part, which will be given by me, will be a general landscape setting introduction for the site. And I'll also be focusing on some case studies on the exploitation of natural resources. So this will be stone and water. And then the second part will be given by Lieven, and that will focus a bit more on the internal urban layout of the city, which is essentially known through geophysical survey. Let's see if I can. Okay, on this this first slide, you can see general location setting for the city. So it's located in the site is located in the east of Portugal, at about 10 kilometers from the border between Portugal and Spain. Now, from a historical point of view, the Roman town of Ammaia is located centrally in the province of Lusitania. It's actually in the inlands of Lusitania, which was in the Roman times the most western province of the empire. Now, the site itself, which you can see here in its general topographic situation, is located south of the Tejo River, the Tagus River, which runs here. And from a landscape perspective, it is a quite diverse region, and it more or less forms the transition between the very vast plains of the central Alentejo region to the south, and the more mountainous landscape of the Pajaros region north of the Tagus River. Now, altitudes in the area go from around 30 meters above sea level to more than 1,000 meters above sea level in this small mountain range you can see here. So we actually are dealing with a rather what you can call a partialized landscape with very diverse or very large geographical, geomorphological and ecological differences. So differences regarding geology, topography, but also present-day temperature and precipitation. Now, specifically, we can actually subdivide this landscape in two broader regions, two broader zones, which I've indicated here with the letter 1A and 1B, which is the general landscape of the northeastern Alentejo region in Portugal, and then indicated here too is actually the region, the area immediately surrounding the Roman town, which is a bit more a landscape, has a bit different landscape perspective. So if I go in a bit closer on this landscape, this is some general views of the landscape south of the city, south of the site. So we're dealing with a relatively desolate landscape of the Alto Alentejo. It consists of very vast glowing plains, softly glowing plains with a geological substratum, which is generally at the surface or very close to the present-day surface. And this has an influence, of course, on the possibilities in that landscape. So there's very few soil developments, and soils are relatively infertile. So, and together with the climatological situation in the area, which is characterized by very high summer drought, makes this area very difficult for agriculture. And as you can see here, the present day economic activities in the area are essentially the growing of low demanding trees, such as you can see here, cork oaks and olive trees, and also pasture, mainly goat and cow. But even in this relatively desolate landscape and these harsh conditions, we see that in the Roman period, the area is characterized by the development of some very large villa estates, let's say. So you can see very large and rich villa estates, from which you can see one of the mosaics here. This is from the site of Torre de Palma, and that gives the idea that this area was relatively well known, or was essentially used for raising of animals, and in this case horses. This is also something which is confirmed by ancient sources, that highly prize Lusitanian horses in Rome for chariot races. We also see that these villa estates, such as this one, Torre de Palma, from the 4th century onwards, so when the general Roman occupation in the area starts to diminish a little bit, we see that these villa estates keep flourishing. This is in contrast to, for example, the city of Ammaia, the town of Ammaia, which starts to experience a form of decline in this period. So you see in this 4th century, despite these harsh conditions, that these villa estates, we see a kind of ruralization of the landscape. So the larger settlements, they start to diminish, and these villa estates start to accumulate more lands, and they become a kind of social and economic and religious hubs. And this is also something that you can see, for example, here on the bottom right of this slide. A lot of these villa estates in the 4th and the 5th century start constructing private Paleo-Christian basilicae. And they start to function as a kind of proto-villages or small villages, let's say. If we then go to the north of the city of Ammaia, so the area to the north, we see a similar desolate landscape, but which is much more, where you can see that the local geology, in this case granite geology, starts surfacing much more. And very typical geomorphological aspect of this landscape here are the frequent occurrences of these granite inselbergs or boulder outcrops. Now, and what is particularly interesting in this area is that it has a very rich megalithic culture. So there's a very rich megalithic culture that has developed here in the later Neolithic period and the early Bronze Age. With at present there's over 700 identified megalithic monuments, from which you can see some examples here. And maybe even more interesting is that within this megalithic culture, we can distinguish two main groups or subgroups on the basis of their geological setting and the landscape and the type of material that they use for the construction of these megaliths. So we have a group which makes use of the local granite, which is located in the southern part of this area. And then to the north, we see megalithic structures, which are monuments which are composed of local shale. And at the transition between these two geological zones, we see also a series of large menhirs that are being constructed, for which you can see an example here. So these more or less mark the boundary between these two geological units. And if we go in a little bit deeper on these monuments, we can also see that in general the shale monuments, the shale megalithic monuments, are smaller than the granite ones. So there's a clear distinction not only in the raw material that they use, but also in the size of the monuments themselves, and also the assemblages, so the funerary assemblages that are accompanying these funerary monuments. There's also a clear difference in that, where you can see with the granite funerary monuments, the granite dolmens, for example, you see much more frequent occurrence of ceramics. You see adzes that are being deposited, millstones. While if you look at the shale monuments, these assemblages are almost exclusively made up of lithic artifacts. And one of the possible explanations here is that for the difference between these two megalithic contexts is that we're dealing with actually two different socioeconomic situations, where we have on the one side the granite group, let's say, which has a bit more sedentary character, has a more complex social structure that was started to be oriented a bit more already to agriculture, where on the other side you have the shale group, which is a bit more, let's say, individualistic. It's a more mobile society where pastoralism was dominant, So you have smaller groups in the shale region, and slightly larger groups in the granite region. And one of the explanation for this has possibly to do with the lower fertility of the soils in the shale landscape. So where people lived in smaller communities, and they were more geared towards pastoralism, let's say. If we then focus focus a bit more on the site itself, we see that this landscape is characterized by a small mountain chain, which you can see here. So northwest southeast oriented. It's called in Portuguese the Serra de São Mamede, and it has peaks that go over 1,000 meters in altitude, and that are locally 400 to 500 meters above these lower lying valleys. And it is in one of these valleys particularly that the Roman town was established or was found. And the presence of this small mountain chain also gives rise to slightly higher precipitation, a little bit more smaller rivers and wells and sources because of this altitude difference. So in comparison to the landscape surrounding Ammaia, so the wider landscape of the Alentejo region, the actual area where the city was established is a bit more fertile than the surroundings. So you can see here on the bottom. On the bottom, you see here the valley in which the site was located, and was surrounded by these higher quartzite ridges, on top of which in medieval and post-medieval times, some settlements were founded that were founded there because of easier defense. Then, if we go in on the site itself, it's actually a site which is known. The location of the site is known already since the early 20th century. But systematic archaeological research started only in the early 90s of the 20th century, so quite recent. And in the first years of the research, the first 5-6 years of the research, the focus was actually on excavation, and on excavation of some monumental remains that were partially still visible above ground. I'm talking about parts of the Forum area with the Forum Temple, a monumental city gate, parts of a small bath complex, and some smaller structures that are located underneath the present-day small site museum. Now, these excavations, together with epigraphical studies, have allowed already to give a little bit of insight into the general history of the site. And we know at the moment that it was founded in the beginning of the 1st century AD, probably under Augustine, in Augustine times, so under Augustus, and that it had its most prosperous period roughly between, let's say, the second half of the 1st century AD and the end of the 2nd century AD. Then throughout the 3rd and the 4th century, the city remained inhabited, but there was clear evidence that large-scale building activity went down, and also the amount of import material, of luxury material, is already significantly lowering. And then the archaeological evidence has also illustrated that at the end of the 4th century, and especially in the 5th century, larger parts of the cities are being abandoned, and the city slowly starts to disappear, and it's completely covered since let's say the 8th century until more or less present day under colluvial material. Now, so we have here indicated in red the zones of the city which have been excavated or partially excavated, and then also since 2008, or between 2008 and 2011, there has been a large-scale geophysical survey campaign that was organized in the frame of the European Radio Path project with the aims of mapping the entire intramural area of the city and its immediate environment. But Lieven will focus much more on that later. But by combining these limited excavation data with the geophysical survey, it was possible to come up with a rather complete plan already of the entire city. And we know now that the city had an area of roughly 20 hectares and had a very regular orthogonal street pattern, very typical of newly founded Roman cities. And maybe interesting to note here is that this entire southwestern part of the city, which was actually a steep slope that was incorporated probably into the city area, but was never built upon. So, and based on these data in a final stadium, these data have then been combined. So, excavation data, prospection data, geomorphological observations, and architectural interpretation to come up with a set of possible reconstructions for this site. So that was more or less a general introduction to the city and to the archaeological site. And then I'll go now to 3 cases which I would like to discuss with you a little bit more in detail. And the first one of that is the water supply for the Roman inhabitants of the town. So water has, together with food production, has always been a very important natural resource for men. So without drinking water, people cannot survive, of course. And this is especially also true in a Roman urban context, where water was used for a large range of purposes. So in first place, this is obviously consumption, so drinking, cooking, etc. But water was also distributed in Roman towns through public fountains, latrines, public and private bathhouses, the elements that are very typical for a Roman city. But also water was used in a high number of industrial activities, such as the production of metals, the production of mortar, etc. Now, to place this in a little bit more in a more context, if we look at the situation in Rome in the 2nd century AD, or in the 2nd century AD, so estimations are that the city at that moment had about 800 to 900,000 inhabitants. The town was fed, water came to the city through 9 aqueducts, and estimations are that about 500 million liters of water reach the city per day. So if you then calculate the number of the amount of water, the volume of water that was available per day per person in the city of Rome, that must have ranged between roughly 55 and 63 liters per day per person. If you look at present-day cities, for example, Brussels, the capital of Belgium, the present-day water consumption there is 96 liters per day per person. In Ghent, the city where I live, this is 82 liters per day per person. And for Paris, this is a little bit over 100 liters per day per person. So you see that the amount of water that was available in Roman cities, especially in Rome, was very high, of course. So water was obviously then also important for the city of Ammaia, for any Roman city, for any settlement, of course. And on the basis of these limited excavations that are available for the city, and the results of geophysical survey, there are a lot of indications on water consumption or water use already for Ammaia. This is essentially what you can see here in the top left of this 3D reconstruction, dealing with a small private bathhouse that was part of a large domus in the city. But also here just south of the Forum, there was a public bath complex that was partially excavated, and there is at least one other possible public monumental bath building known in the city through the geophysical survey. Apart from that, we can also imagine that there must have been other places, other houses with private bath buildings, but also fountains, latrines, and the industry. So the amount of water that was needed in the city on a daily basis must have been also quite elevated. So we're dealing with a city here which has probably between 2,000 and 3,000 inhabitants, if you judge from the occupied area of the city. So what you can see here on the right is actually the bath building, the bath complex just south of the city forum that was partially excavated. And one of the main elements here, you can see this here, was that this building had a large swimming pool. And this swimming pool must have had, based on its dimensions, contained between 85,000 liters to 90,000 liters of water. And of course, this had to be refreshed on a regular basis. So that means that there must have been a supply of water to this particular building. And there's also some elements of this supply system that have been unearthed already. So in the upper part of the city, through a very targeted excavation, there were remains of a small aqueduct that was part of this supply system. But also in the geophysical survey of the forum area, underneath the forum square, there are traces of aqueducts or of the supply system that have been discovered. Now then the question is, of course, where does this water come from, and how does it reach the city? Now, a very obvious first source for this water supply are the different smaller different rivers that or different small streams that are in the vicinity of the city. So these must have been without doubt important for the inhabitants of the town. So this must have been important for the inhabitants of the town to supply drinking water, even without the need for construction of aqueducts. And the most important, of course, most important for the city of Ammaia was this small river that ran just east of the city, the Severe River here. And this is it's one of the larger rivers in the entire area, and it contains water throughout the entire year, which is very important, of course, that there is a continuity in supply of water here, especially given the climatological situation that we are in here. So we have a very dry summers, but even throughout summer, even though there isn't much water, there is still water in the river. So all good and well, but of course this river is located lower than the city itself. So this is not a possible source for feeding the internal aqueducts and for feeding the bath buildings, for example. So there must have been other sources in the area which could have supplied the city. So if we then look at the geological map, we can see that we can see here indicated with the red arrows that the entire western flank of the hill just east of the town was actually a contact zone of dolomitic limestone, gravel deposits, and shale and quartzite. So this is an area where, based on the geological situation, there are a lot of sources, natural sources, natural wells on this contact zone. And some of these, for example, the one you see here on this photo, is actually a source which is still used today to provide water to a nearby town, the town of Porto Alegre. It's a town of 20,000 people, and it has it provides about, at present day, still 50 liters per second of water. So together with the river, the Severe River, this source is already an important or important elements for the water supply of the city. But then again, this source was located lower than the bath buildings of the city. For example, this source is located at an altitude of 530 meters above sea level, while the city is located between 525 and 570 meters above sea level. And then if we look particularly at the Forum Bad complex, this one is located at 540 meters above sea level. So that means that there's still other sources that must have existed to supply the ancient city, or at least the upper part of the ancient city, with flowing water. So if we then look at the elevation, the topography of the terrain surrounding the city, and the geological map, there was actually only one possible candidate for supplying running water to the city, and that was a very small stream. It's a side river of the Sefer River, and it's a small stream that originates about 3 kilometers west of the ancient city. And again, like the Sever River, this is a river that contains water throughout the entire year. It's also in the dry and the warm summer months. And during field observations on the location on an altitude of 580 meters above sea level, and on the transition zone between the granite geology, the quartzite ridges, and then the sedimentary geology on top of which the Ammaia was built, we found some remains of an aqueduct system that was constructed in a similar way as the aqueducts that were unearthed in the city. And we were also able to trace through, for a large extent, you can see this here on this little map, we were able to trace the aqueduct for about half of its trajectory in the direction of the city. So this was the first small case study on the water supply of the city. If we then look at the material from which the city was built, we can, well, if we go in a little bit more general, for the one of the most typical elements of Roman urbanism and of Roman architecture was the use of stone. Look, think, for example, of the Colosseum in Rome. And we know there are estimations that between the 1st century BC and the 3rd century AD, so at the height of Roman architecture, Roman culture, that there was more stone consumption, more stone being consumed than in the entire 1,000 years before and the entire 1,000 years after that in Europe. And also, for example, in the case of Ammaia, we're dealing with a city which was founded completely from scratch, so it was an ex novo foundation, and also a city which was quite monumental if you look at this reconstruction. So there was quite large-scale building activity going on, and this is a region in Lusitania, inland Lusitania, where large-scale building activity and urbanism, and especially stone architecture in pre-Roman period, was not very widespread. So this means also that a complete stone supply system had to be started from zero in this area. And particularly for Ammaia, the primary building material was, you can see here on the square of the south, near the south gate of the time, this was granite. In order to identify then the origins or the provenance of this material, an obvious first step, of course, is to look at the geological map of the city and its immediate hinterland. And what you can see here, so we have the arrow, yeah, we have the site of Ammaia here, and everything to the north of the city, so with the plus symbols, these are all granite outcrops. This is part of the granite geology of the region. And essentially based on thin section analysis, it was clear that the origin of the Ammaia granite must have been was part of this large granite intrusion here. But even within this granite body, there were small scale variations, textural and mineralogical variations. So we had to come up with a method, or we had to do some very detailed sampling of the differences within that granite geology there. So what we then did was sample all different types of granite that were available in the hinterland of the city, and also we looked at possible traces of ancient extraction. So in a second step, after this geological assessment of the region, we did field observations in an area of around 15 kilometers around the site to look at potential extraction locations, potential extraction site. Now, this radius of 15 kilometers around the city, this was determined based on other geoarchaeological research that has illustrated that stone quarries for building material in the Roman period are generally located less than 15 kilometers from the spot where it was later used. This 15 kilometers is based mainly on the fact that this is something that you can travel within 1 day, for example. So, and then based on this survey that we did, this field observations, we were able to identify 4 potential extraction sites, which I have indicated here on these 4 photos. And all of these sites show very similar ways of extraction, very similar extraction methods, techniques that were used. But these 3 of these 4 sites were actually very small sites, where only a very small volume of granite material was extracted. There was only one site, the one on the left bottom here, that was potentially large enough to have supplied or to have supplied the building material for building an entire city. That was the site of the quarry of Pitarania. So we have some images of that site here, and there we in the first survey we identified over an area of about 10 hectares. We found traces of ancient extraction. Now, and the landscape that as you can see here on these photos is again characterized by this very typical outcropping pattern of these granite inselbergs, with a very wide range of sizes and of shapes. Some of these outcrops are over 20 meters in diameter. And traces of this ancient extraction, we found them throughout spread across an entire hill, spread over this entire hill. You can see this on this hill here. We found throughout this entire hill, we found traces of the ancient extraction. Now, of course, in order to better understand what was going on here, it was crucial to have a kind of base map, so we can start mapping the morphology of this ancient quarry site. And based on this very complex landscape here, this was not very easy. Plus, also we have to take into account we're dealing with a quarry site here, so a lot of material has been extracted. A lot of things have been moved around. So this is a landscape which was very was highly scarred. Let's say this is highly modified through human activity. So in order to better understand the complex layout of the quarry, we came up with a method to start mapping this complex site. And one of the prerequisites here was that we're dealing with a complex site, but this mapping cannot be too time-consuming, cannot be too expensive. So traditional methods such as total station mapping, drawing, GPS measurements were not really an option. So in what we did then, we're talking about more or less 10-15 years ago, we used a structure from motion approach based on aerial photographs, over 300 aerial photographs of this entire area, that we could then transform into a highly accurate elevation model and orthophoto of the city. That was then used as a base map to start mapping the archaeological traces of the extraction. So you can see here a very general interpretation map of the site, And where you can see here zoomed in traces of very small extraction fronts that from which the actual blocks were quarried. And this is using by combining this base map with going on the field and measuring and doing field observations, looking at the type of extraction activity. We could deduce that we're dealing with a site, a quarry, which was characterized by a high number of very small extraction areas, and these extraction areas, they were all defined basically by the outcropping pattern of the granite geology in this area. So these extraction fronts, they range from very small, so 1 meter in length, to larger fronts of over 30 meters in length. Also, the height of these extraction fronts range from half a meter, as you can see here on this photo, to some extraction areas that were over 3 meters high. So it was actually quite more an opportunistic way of extraction. So not particularly what you can think of a Roman quarry with very systematic, regular extraction, but there's much more opportunistic, and this was determined to a large extent through the outcropping pattern of the geology there. Then, as a final short case, that I would like to talk also a little bit about the decorative stones that were used in the city. So the marbles. So, and at the beginning of the case on the granite, I mentioned that the building industry and the production of building stone was very important for the Roman economy, for Roman architecture. This is also very much the same for decorative stones. So this is a little bit of an analogy that I would like to give. So marble or decorative stones for Roman society was a luxury symbol, and this kind of a status symbol, you can say. And these status symbols, they are a visual expression of someone's social and or economical position or status. And they are used, status symbols like this are used by individuals or by group to distinguish themselves with the aim to obtain a higher status. And luxury products are a very good example of these kind of status symbols. And very particular, or in many cases for these status symbols, is that the brand name or the logo is very prominently visible. They are easy to recognize. But like other symbols, status symbols, they can change in value and change in meaning throughout time. So what is now a status symbol was not necessarily a status symbol in the past, and vice versa. And also these symbols are culturally dependent. So what for one culture is a status symbol is that not necessarily for another culture. And this is actually the same for decorative stones or for marble. So the Roman society, for anyone who deals with the Roman world, with Roman society, knows that this was a highly hierarchical society, and that the Roman elite, they were constantly striving to showcase, to maintain, and to increase their power and prestige. And one of the most powerful means for doing this was in the Roman world was monumental architecture and sculpture. And the grandeur of this monumental architecture and sculpture was not only expressed by the sheer investment of manpower or money, but also by the decor that was used for decorating these buildings. So architectural decor was considered by the Romans an integral part of a monumental building, and it contributed substantially to the message that the building conveyed as a whole. So the decor, the marble used, the sculpture, it was intended to be seen by visitor. It acted as a social marker with a clear communicative effect on people looking at on outsiders. So like other status symbols also, these marbles, these decorative stones that were used, people could identify these different types. They knew where they came from. They knew what their value was. Now, of course, marble is not specifically related to the Roman period. Also in classical Greece and in later periods, this marble was essentially used, substantially used. But very specific for the Roman world is that for the trade in decorative stones, is that this was the beginning of the large distance trades. So marble was introduced in Rome itself during the later Republican, and then especially from the Augustan Tiberian times onwards, and especially in the 2nd century, around the turn of the 2nd century AD, there was a high demand in marble in Rome itself, but also in cities around Roman cities around the Mediterranean, with white marble and polychrome varieties of marble being distributed in huge volumes and across the entire Mediterranean or the entire Roman world. So this small diagram here gives more or less a schematic overview of how natural stone and specifically then how decorative stones such as marble, how they arrive in the archaeological record and the different types of human activities or actions that are the basis of this marble assemblages in archaeological records. So I'm basically the goal of this case, this final case that I would like to discuss, is tracing back how a marble artifact, from the moment it's being that we recover from the archaeological record. This can be a statue, a piece of statue, a small piece of veneer. So we would like to trace back its original location, its provenance, and on the basis of that, we can then start to reconstruct the entire biography of this marble object. But crucial in this aspect is of course the provenance determination of the material, the raw material. Now, this correct characterization, identification, and provenancing, especially for white marble, can be a very difficult, is a general a very difficult task. It's not a straightforward task. As you can see here on the left, variations in color, texture, and structure of these marbles are very rare. So marbles from different source areas. You can see here 6 examples, ranging from Italy, marble sources from Italy to Greece, Turkey, and to Lusitania, to Portugal and Spain. You see that these are visually very similar, but also within one particular quarry area, there can be quite some variation. So this means that by purely visually, it's impossible to start provenancing this type of material, and more complicated or advanced scientific techniques are needed to define or to be able to define the compositional, isotopic, and chemical differences between different sources of marble. Now, and specifically for white marble, this is generally done through a multi-method approach, where different methods are combined, essentially mineralogical petrographical observations with stable isotopic analysis, and then depending on particular situations, complementary techniques can also be applied, such as electron paramagnetic resonance, trace element analysis, cathodoluminescence, or in the case that I'll be describing for Ammaia, also transform isotopic analysis, for example. Now, a first step, if you want to do this provenance determination, so we're dealing with material that was distributed over long distances. We know that marble in the Mediterranean, in the Roman Mediterranean, was moved around over large distances with quarries located in Turkey that exported even to Belgium, to France, to northern France. So there's a lot of movement of this material. So first step in this type of provenance studies is to have a good, reliable geological reference database, of course. So you need to have sample data set or a geological data set which reflects all or which contains all possible sources. So I've listed here some of the main marble source areas for the Roman Mediterranean, and on this slide also with a particular focus on the Iberian Peninsula, which was for the case of Ammaia, of course, very important. And then we can see that in the Iberian Peninsula, you can see you have marble source areas. You have essentially 3 large marble source areas. So you have one area in the north, which is in the Pyrenees. You have one in the southeastern part of Spain, in Andalusia, and then you have one in the inlands of Lusitania. And this is actually very important for the case of Ammaia. There is one large marble outcrop area, the Estremos anticline, which outcrops only about 50 or 60 kilometers south of the Roman city. And what is very, very nice here is that this marble area, the Estremos anticline, is at present about 60% of all high quality white and coral marbles in the Iberian Peninsula is still from this area. So it's a highly it contains marble of high quality, and it's still at present day highly valued. It's essentially in the southern part of this geological unit that the high quality marbles can be found. But as I said in one of the earlier slides, there can be a high variability in marbles within one marble quarry area, and this is also the case for the Estremos area. So you can see here 9 different varieties of marble which come from that one particular zone, and this goes from completely white marble to almost dark gray, almost black marble with all kinds of variations within it. But also, yeah, this essentially the white variety is very similar to other white varieties, to other white marble varieties from the Mediterranean. So, and if you then look at, there are also traces, despite the fact that it's very highly, this landscape is, because of modern extraction, is highly altered. There are still few traces of ancient extraction visible here. And you can see here the very typical, much more systematic extraction. So not very much like what we saw in the case for the granite, but it's much more regular extraction, much more systematic extraction. Now, this marble area was, from a geological or archaeological point of view, not very well examined yet. So there was very little known about the specific characteristics of the marble in this area. So of course, if we wanted to look at the provenance of the marble from Ammaia, it was very important to have a good knowledge on the different varieties and on the characteristics of the marble from Estremos. So what we then did was, in first instance, did a geological survey in the marble area, with where we took 34 samples from 11 different locations in the area, which I've marked here. Now these locations, they were determined primarily by the fact locations where we found traces of ancient extraction. Those were sampled and studied, but also we wanted to have the full variability of the marble within the area. So the full mineralogical, petrographic, and geochemical variability was reflected through our sampling. Apart from that, we also took samples from 17 white marble artifacts from the city, with a chronology ranging from the middle of the 1st century AD to the end of the 3rd century, in order to have an idea of chronological variation in marble imports at the city. Now, the method that we essentially used to determine the provenance of this of the Ammaia marbles was, in first instance, by looking at the mineralogy, the texture, and the structure of the marble, and essentially looking at the maximum crystal size. So what you can see here, two different samples from the Estremos area, where you can see these both thin sections, microphotographs are on the same scale. So you can see that there is a lot of variation in the maximum crystal size there. Then on this graph, I also illustrated from different quarry regions from the Mediterranean area, so this variability and maximum crystal size. So you can see the site of Estremos here. But what clearly is illustrated on this graph that you have some quarry marble quarries which display which have marble with much more coarser grains than others. For example, you have the Naxos marble, which has grain crystal calcite crystals going up to 8 millimeter in diameter, while, for example, the Carrara marble, the famous marble from Italy, has on average a maximum grain size of 1 millimeter. We also looked at other aspects of texture and structure. So we didn't only look at the grain size, but also at the grain size distribution and the boundary shapes. So these three elements, so grain size distribution, and boundary shape, these are all elements which are related essentially to the circumstances, the situation in which this marble was formed, was metamorphosed. And you can see here that there is a lot of variation between these different source areas. Then, particularly for the case of the Ammaia marbles, we combined these mineralogical and petrographic examinations with strontium isotopic analyses. Why strontium isotopic analysis is because this is strontium isotopes can be used as a geochronological marker. And we know, for example, that the marbles on the Iberian Peninsula are almost all of them are Mesozoic in age, Paleozoic in age, excuse me, while the marbles from the Mediterranean area are mainly Mesozoic in age. So they originate from different geological periods. And strontium, so strontium is one of the trace elements in marble, and the strontium isotopic values of marbles, these are determined by the environment in which the stone or the marble was formed. So they reflected the geological history of the material. So you see on this graph here the variation through time, through geological time of strontium isotopes or seawater composition, and so the seawater composition in which these marbles were found. And you can see, for example, that the strontium isotopic composition of seawater in the Paleozoic, so here on the left, in the left rectangle, was on average higher than the one from Mesozoic marbles. So by using the strontium isotopic method, the idea was that we could already start to distinguish whether the fact the marble in Ammaia was coming from the Iberian Peninsula, or whether it was imported from Mediterranean quarries. So in this box plot, you can see the isotopic strontium isotopic values of Iberian marbles in relation to that of Mediterranean marbles. And here indicated in red are the Paleozoic marbles, in green the Mesozoic marbles. And you can see that these Mesozoic marbles have lower values of strontium isotopes. If we then compare this with the values for our archaeological samples, so at the top we see here strontium isotopes. We can see that the Ammaia marbles show a very limited range in isotopic values, which corresponds very well to the values for the Estremos area. with a very small chance that they also could be related to marble from, in this case, Almadén de la Plata, which is in present-day Spain, or the marble from Pentelicon near Athens, and a very small chance that it could also be from the island of Thasos in the Aegean. By comparing then also the maximum grain size, this was a little bit less conclusive. All of the samples from Ammaia are relatively small grains, have a maximum grain size lower than 2 millimeters, and this corresponds to most typical Mediterranean or to most marbles that were used in the Mediterranean, from the Mediterranean or the Iberian Peninsula. But based on by combining these two methods, we were able to deduce that there was a very that the marble from our Roman city most likely came from the nearby quarry areas of Estremos, which was, in a case, of course, not very surprising considering the high quality of the marble there and the geographic location. So it was located quite close to our city. And I think I have 2 more slides to contextualize these marble results a little bit. So this situation, how does this situation in Ammaia then relate to the situation in the rest of Lusitania? Is I have here 3 statues from Emerita Augusta, so the present city of Merida, which was the capital, the Roman capital of Lusitania. And you can see here, for example, these 3 statues, they all bear the same inscription. So they are all made by ex officinae Gaius Aulus. So they were all made by the same. These 2 are made by the same workshop of Gaius Aulus. If you then look at where this material come from, so there have also been provenance analysis on these 2 Togatus statues. We can see that this one, the one on the left, was made from marble from Carrara, while the one on the right was made from marble from Estremos. So this means that you have workshops in the city itself, which work with different types of marble. So this not just first of all, this does not mean that all marble from in the capital of Lusitania was from one particular source area, was all imported, but also that there were people working in the city, working on different types of marbles. And this is also very interesting here on this Togatus statue here. This was signed by a Greek sculptor, Demetrios, working with Estremos marble. So this means that there are actually Greek people traveling to Lusitania to work on the local material. So that there was a huge mobility in the people in sculptures, let's say, and in marble, in the spirit in this area of the western part of the Roman Empire. Then there is one more slide. If you look at, for example, more on the architectural use of marble in Emerita Augusta, you see here the Augustan, the temple of the imperial cult in Emerita Augusta, which was founded in Augustan times, and which used exclusively local materials, local granites. So marble was not yet used in this for this construction. While if we go to the Flavian period, so the end of the 1st century AD, we can see a lot of the use in this theater here, the use of a lot of marble sculpture, marble columns, marble veneer, with a combination of material imported from the Estremos area as well. So we have white and gray marble from the Estremos area, combined with colored marble or colored decorative stones from Spain, from Portugal, but also combined with imported material from the Mediterranean area. And so we see here that is a situation where we have in the initial phase of the initial urbanization phase of the city in Augustan times, which uses mainly local materials, then a gradual shift towards the import of marble So at the end of the 1st century, the import of marble from regional sources, but also from the wider Mediterranean. This is also something that we see in other Lusitanian towns, for example, in Evra, where we see that the temple of in Evra use a combination of materials. So we have the granite material, which was local, was quarried 10 or 15 kilometers from the site, and this was combined with white marble from the Estremos area. So I have some final bibliographic references here, and this is essentially what I wanted to say on these 3 case studies on the natural or the resource exploitation or the resource trade, the resource economy for the Roman city of Ammaia.
So good afternoon or good evening, everybody. In the second part of this lecture, we'll focus a little bit more on the geophysical prospections that took place at Ammaia. So first of all, I should say that it's not just my own work that I'm going to show here. It's the work of many people, universities, also commercial companies. Perhaps let me first try and give you a description of what geophysical prospection is. So there are different elements in there. I don't know exactly what the background of all of you is, so I'll give some technical background, but not too much. I'll focus mainly on the applications in Ammaia, and we can always come back on the technical aspects in the question time, I guess. But for this definition or this description, we can say that geophysical prospection looks at the physical properties of the soil, and that could be many things, but the most important ones are these 3 here. So magnetic, electrical, and electromagnetic, which I will explain later on. Then another element is that it is non-destructive, so very important, as opposed to excavations or quarries. And it is close to the surface, so as opposed to remote sensing techniques like aerial photography or the things which Davy already showed for mapping the quarry. So another thing is that that this can result in what we call anomalies. So what are anomalies? Those are measurements that are different from the normal background, let's say. So there's something happening there, and that something is then approximately representing what we're looking for the archaeology. I say approximately because with these prospection techniques, we can never have, of course, an accurate image, an absolutely accurate image of what is buried in the soil. So there are 4 very frequently used methods. There is, first of all, magnetometry, there is electrical resistance, and then there are georadar and electromagnetic induction. And 3 of those were applied at Ammaia. The 4th one, electromagnetic induction, is also a really important technique, but we didn't use it, so I will not discuss it here. And with magnetometry, we covered the whole territory of, or the whole intramural zone of Ammaia, and also a large part of the extramural area. Whereas with the 2 other techniques, it was only selected areas that we were able to cover. So let's start with the first technique, with magnetometry. So I'll discuss them, each 3 of them, one after the other. So when we look at magnetometry, I could show you this image, and perhaps some of you a long time ago or not so long ago did this experiment at school, where you have the iron particles that are on a table, and then you put a magnet also on the table, and you will see that those iron particles will rotate slightly and will start to align along a certain pattern, and that pattern is the magnetic field, or the field of this magnet, so the magnetic field, and those are the magnetic field lines in the pattern which you can see. And now the interesting thing is that our own planet, the Earth, can really be compared to such a magnet and also has magnetic field lines. And now, if we look at those a bit more closely in our own region in Western Europe, we can see that those field lines enter the surface at a certain angle of about 70 degrees in our region. And we can measure that. But more importantly, we can also measure local variations in that magnetic field. That magnetic field will not be the same everywhere. And those variations could be caused by an object that is slightly more magnetic and that is buried in the soil. And that could also be, importantly, that could also be an archaeological object. Then it becomes interesting for us archaeologists, because how can this little object come there? What can it be caused by? First of all, there we should say that in nearly all soils, and those soils will gradually become more magnetic with time. It's a slow evolution, but gradually that happens because of different phenomena or things that can occur. First of all, fires that can be natural or that can be caused by humans. It can also have something to do with bacteria, especially in combination with the presence of organic matter. And so if we look at all this, we see that it could be natural processes, but there is also a very important role of humans and of human settlements. So that's what is indicated here in this image. So the soil becomes more magnetic, and then how do we arrive at such a small object here? And that could, for example, be by digging a pit or a ditch or something else. And that ditch can then, when the settlement is abandoned, can then be leveled. But what remains underneath the surface is this. So there is something that remains and that stays there, well, you could say nearly forever, and that we can measure. So that's what I mean with this little thing here. For example, this ditch. Other very high readings we can get when things are heated to a very large temperature, to above about 600 degrees Celsius. And that's why we can see things such as pottery kilns or industrial archaeological sites or fireplaces and so on. So those are all things that we can see, but how can we see them? What does the instrument look like? Well, this is an example of the instrument which we used at Ammaia also for the measurements. Nowadays, there are instruments that are much more efficient and quick. This one, for example, has several sensors. So if these are 2 sensors, this one has 8 or 10 in a row, is equipped with the GPS system to know exactly where we do all the measurements. And as you can see, is also pulled by a vehicle, by a quad. So this is much more efficient. But at the time, 10 years ago, we were doing it with the handheld instrument. So if we look at a few characteristics of that magnetometer survey, you can see here that it can detect lots of different archaeological traces, such as the kilns, which I mentioned, and the ditches, the pits, but also foundations, which are really important for Roman towns, of course. The speed can be really high, so for that reason we were able to do the complete area of the town. But a disadvantage can be this, that there can be iron debris or small iron objects that are in fences along or at the borders of the fields, but that can also be if there are small parts that can be lying at the surface or just below the surface. We don't see them when we walk over the field, but we can see them in our measurements. So let us look briefly at what that gave as results for Ammaia. So as I said, we did the whole intramural area, about 18 hectares. So that was work done by Paul Johnson. And if we look at the results, this is what they look like. Perhaps it is best to go a bit more in detail in one area, this central area here around the forum, where we can see that there's a lot happening here. So this is the forum, but there's also many other traces of buildings, most of which are residential, so they're house blocks. And what is interesting here, if you look at this scale bar here, so don't worry about this unit here, about this nanotesla, which is the unit of the strength of the magnetic field, as I explained. But just look at the numbers here, so minus 20 to plus 20. So this is less magnetic than this. And then if you look at all these traces here, they are white, so they are in fact less magnetic than the background soil, you could say, which is something that often happens. But it is important to know that it is here what we call a negative anomaly, because the interesting anomaly is less magnetic than the rest. Here again, we see the same thing here in the interpretation. So all the red traces are those negative anomalies. Again, zooming in a little bit, we can see this again, and it's interesting to also look at this table a little bit. Why is it that those traces are less magnetic? If you look at this table, you see that what could be the building, or what probably are the building materials for most of those houses, for example, granite. Again, don't worry about this this here, but just look at the numbers of the magnetic degree of those materials. So granite has 50, whereas some of the minerals that are in the soil, of course, not the complete soil consists of those minerals, but they are in there, and they are much more magnetic. And so that's part of the reason or the explanation why those buildings show as negative anomalies. If we then look at the positive anomalies, so in dark green here, we see that there are really few of them. There's a few ones here, which probably correspond to the streets. So here, they are at the location where the streets are. And there, we don't know exactly what the streets were paved with, but probably it wasn't very magnetic material. So probably the most plausible explanation for these positive anomalies is that where the streets ran, there was an accumulation of soil later on when the city was abandoned, which could give this positive signal. This could be true especially for this here, which is a cryptoporticus, so a kind of a basement underneath the portico of the forum, and especially there could be an accumulation of material which could also contain roof tiles and ceramic, which are things that would cause normally a positive magnetic anomaly. Then there are also modern disturbances at Ammaia. We can see some on this plot here, all these things that disturb our image. Many of them most probably are caused by modern debris, as I explained, that is near the surface. Although some of them could have an archaeological meaning, it's not always so easy to exactly interpret that. And the same is true for this here. This most probably is a modern conduit, but we cannot be entirely sure. It could also have it could also be ancient. Now, when we look at the archaeological interpretation of that, or further look at that, what can we do with all the magnetic data? Then we can look at what in general can be questions which geophysical prospection can answer, as opposed to excavations, which are small in scale. Geophysical prospection is really useful when we look at questions that need an extensive area, let's say. For example, how was the planning of the city. And here Davy already showed images that also showed this, that the city is planned very regularly. We can see the streets running here and also in this direction. If we filter it out a little bit, we have this plan of the streets. It's a very regular plan. It's not always like that in Roman cities. If you look at Rome, you will have a completely different picture. Just to give an example, at what else can we look when we are using geophysical prospection? For example, at the distinction of public and private space. And here it is really only in the center that we are sure that there are public monuments. For example, the forum area here and the adjacent baths here. And all the rest of the town is mainly occupied by domestic buildings, so houses, although there can also be some shops along the main streets, so these little ruins here. Other question of a possible or other example of a possible question we can ask from our geophysical data is the boundaries of the city, the extramural area. And here Eastern Atlas did also quite a large survey of the extramural area around the city. So this is the city wall in green. And again, we could look at a few fields more in detail. For example, this one, where the city wall is here, and where we can see that, in fact, the pattern that we see inside the town just simply goes on outside the town with buildings in the same orientation, also here in this extramural area. And again, note that again they are the negative magnetic anomalies. If you look at the scale bar here, they are white as compared to the surrounding soil. In the same field, there was also an artifact survey carried out, and there were different conclusions there. First of all, there was mainly building material there, so which has something to do, of course, with the things we can see in the geophysics. So material when all these structures here started to collapse. But there was also pottery among the finds, and that was mainly interpreted as secondary refuse, which means that pottery was not used there, but was dumped there afterwards, probably from inside the city. It was all dumped in this field. But what is important, and what is often the case in geophysical prospection, is that we cannot have a direct relationship, so we cannot directly explain the geophysics by looking at the potsherds or the building material here, because there's no direct relation between the location of the sherds and the geophysical traces. Let's take a look at another field here in the extramural survey, where there are a few nice examples of funerary monuments along a road that ran more or less like this, and which left the city here at the southern gate. So this was where all probably the Wolof people from Ammaia erected their funerary monuments along this road. So that was it for the first technique, for magnetometry. Let's take a look now at the second one, which is georadar. So how does that work? The other name for georadar is ground penetrating radar. And that's there. The basic idea is that we will send waves, so radio waves or microwaves, so the same ones as you use when you use your microwave oven or when you use your mobile phone. Same kind of waves we will send into the soil, and those could be reflected if they meet transitions between different materials. And the main difference that there should be in order to have such a reflection is that there should be a difference in moisture content. Basically, it's a bit more complicated than that, but that's basically what it comes down to. And then we will measure the time for the wave to be sent, be reflected, and be received back by the instruments. That's what we're going to do. But that can happen at different depths. So it could happen here, and it gives this result here in the graph. And it could happen again at a greater depth. And again, we have a signal here. If we plot this complete graph, or if we put this one in here, this we call a trace. So if we do measurements at regular distances within one line, so for example, each or every 10 centimeters, for example, if we put them all in one bigger graph, then we get this, we get some kind of a vertical section through the soil. But because that's not always so easy to interpret, we prefer to put several vertical sections together and then try to extract horizontal slices instead, because those are much more easy to interpret usually. Here you can see streets and walls of a Roman city, for example. So georadar is a 3D technique as opposed to the other ones. This is when we put all the vertical sections together, we get this 3D data cube, as it is called, and then we can, as I showed, we can extract information from different depths. As you can see here, the walls and the boundaries of the walls are quite sharp. So these images have quite a high resolution. That's another advantage of this technique. The disadvantage of this technique is that in certain soils, so for example in soils with a lot of clay or in very wet soils, the waves which I was talking about can lose their energy. They can fall apart, so to say, and that means that they will not be reflected and that we will not get them back at the surface. But it can also cause, if it's not as bad as this, it can also cause the image to be of a lower quality. When we have, for example, rain, then if this is twice the same area that has been surveyed, after the rain, it could happen that the quality deteriorates and that certain traces are no longer visible. So for the instrument, this is what was the simple version of a georadar with two basic components. So the transmitter that sends the wave, and then the receiver that will later receive the wave back after it has been reflected. Nowadays, most instruments are a bit more comfortable, so you can push them with a nice card here. But as with magnetometry, again, there have been systems invented, like this one here, for example, in this yellow box. There are several georadar instruments, so it could be up to 10 or even 20 instruments, which again will speed up the field work a lot. In this little film, you can see how it can happen when we do the measurements in the field. This is the instrument we are using at our department. Sorry. Again, looking at a few characteristics of that technique as a summary. So again, we can see different kinds of traces with it. Foundations are very important for Roman towns, floors also cavities. So for example, walls that have not been that have not collapsed, we could see with it. It has a good spatial resolution, but as I said, this drawback that in some soils it won't work. It just won't work, this technique. Again, let's take a look at what we were able to do at Ammaia. So as I said, we were not able to do the whole area, which had been done with magnetometry. We did some selected zones. So we could first look at this one here, so the forum. First of all, we should say that the results fitted very well into the street pattern, which had already been revealed by the magnetometer survey. The streets here really fit perfectly in the magnetometer data. Just to give you an idea, a few widths of streets which came out of the data. So widths of up to 12 meters, so quite wide streets. And then the forum data themselves show a forum, as Davy already showed, that is in 3 parts, we could say. So there's first the temple, and there's a middle part with porticos and with tabernae, so shops on both sides. And then there's this building here, the third part, which is a basilica, so a court building, which also may have served as covered markets and other functions. So we made an interpretation drawing of all this. You can see that again. And since GeoRadar is 3D, it's 3-dimensional data, we can also make a 3-dimensional diagram of that, which again shows exactly the same, but we can see some of the differences in the elevation also here. We can see the height of some of the foundations. And we can then compare this kind of forum with other examples on the Iberian Peninsula in Portugal and Spain, and we see that there are really quite strong similarities between other fora of other cities, with the basilica here, for example, and with the temple also in a separate part here. This part here is the bath, so the thermal building, which still has a few very impressive extant remains. And if we look at it, we see that part of it was excavated, and that the survey was complementary to those excavation data. And again, we can compare with baths elsewhere in Spain and in Portugal. And this one, for example, resembles quite well. If we flip a bit this image here or mirror it, we can say that we can see that there's also this here. So this is probably a basin which is situated here at Ammaia, and then this bigger basin, this swimming pool is here at Ammaia, and then this here corresponds to the hot room and the cold room and the tepid room that are here in this example here from Koningbrugge. Part of this bath building was also excavated within as part of our project, and you can see this excavation drawing here. And so again, this is exemplary for geophysics as a whole. You could say that the excavations were able to give relatively fine dating evidence, so from the first century AD to the 5th century AD. But as you can see, the geophysics then can give the context for the excavations here in black. The wider context, for example, here underneath this road here, which it would never be possible to excavate, the GeoRadar was able to do measurements and give us an impression of what is buried there. Here you see a picture of the basin in the center of the baths building. And then we could look at a different area, which is a residential area west of the forum. Lots of traces, as you can see, lots of houses. So we cannot discuss everything in detail, but let's look at this one, for example, which is this one here. So you see the data and the interpretation. So this here in red was a large peristyle house, so one of the largest in Ammaia. And again, here it was useful to compare it with excavated evidence from other towns in Spain and Portugal, to try and find out what the function was of some of these buildings, which we can see in our GeoRadar data. And by comparing it, we can, for example, assume that the entrance of the house is this here, or this could be both. here we have a parallel that the vestibulum, so the entrance is here. So it's possible that the entrance was here. Here then there could be a few reception rooms. And this one, number 5, could be, as in this example here, could be the triclinium, or the dining room, so the most important room of the whole house. Again, here on the map are the different sites where we found the evidence. Again, we can also look at that in 3D, and that can give us some more information, for example, on the doorways, which are more clear if you make the drawing in 3D. Or you can see small details, even like these steps here, which the architects or the builders of the house try to follow the topography of the town, which slopes down here in this direction. There are also parallels with houses elsewhere. For example, here in Volubilis in Morocco, we can see a view from the triclinium into the courtyard, and that's exactly the same as when you're looking from here, from the triclinium into the courtyard here. So very strong parallels that we can find. And this here is one of the houses which I showed, so the Casa de los Pajaros in Italica in Spain. I'll briefly show that film. It's not long. It's also not of terribly good quality, but I think it shows quite well what the house may have looked like, which we had in our data. So there's the entrance probably here, and then the courtyard here. So we enter the house from the entrance. This is the courtyard with rooms on both sides of it. We go through one of the corridors around the courtyard, and then we go towards the triclinium, which is this room here. So it's the largest room of the house. And here again, view from above with the triclinium, the courtyard, all the rooms alongside it, and then the entrance, which may be different from our house. So we can also take a look at the smaller houses, and that's something that is often very difficult in geophysical data, that is to try and individualize individual houses from all this data here. But anyway, we gave it a try, and these were the ones that we were relatively sure about. And then, sorry, some of these here are a bit more hypothetical. In this case, we had 10 house units within this block here, so it's a bit hypothetical. So that was for the second technique, the georadar. We could now move to the third technique, which is earth resistance survey. And here the basic idea is that we could inject a current into the soil, and that current will always avoid to go through walls, for example, that have a high resistance, as it is called, a high electrical resistance. And instead, the current will prefer to go through a ditch. And why is that? That again has something to see mainly with the moisture. There will be more a higher moisture content in this ditch, so the current will prefer that. As with the other techniques, there should always be a contrast between the archaeological traces and the background, so the background soil. And here, with what you can see, has a high resistance. These walls here have a higher resistance than the surrounding soil. Again, taking a look at the instrument, this was the instrument where this type of instrument was used at Ammaia. And what is shown here a bit more clearly with the arrows are the electrodes, so the metal parts which have to be pushed into the soil every half a meter or every 1 meter. So this is very labor intensive, and that explains why this technique is unfortunately not used so frequently these days, although it can give great results. And going a bit more in detail on that, we need, so as you can see here, we need 4 electrodes, so 2 of them to inject the current and let the current leave again, and then 2 other ones with which we can do the actual measurement. So what we will measure technically is the potential. So the voltage is perhaps a term you are familiar with, the volt in your in the socket in your house, for example, you can compare it with. And then the resistance is when we divide the potential by the current. So that's more the geophysical background. Now, going back to what the instrument looks like, what is often done in archaeology is to separate the 4 electrodes so that we have 1 pair of electrodes that are moved on this frame here, and then another pair that is in the field and is not moved, and both of them are connected via a cable, which I think you can see here. I hope you can see it. That was also the system which we used at Ammaia. So there's only 2 electrodes then which you have to push in the soil, a little bit less hard work, although the soils can be very hard, and that's another difficulty sometimes in Mediterranean regions. Let's again look at a few examples. Again, work by Paul Johnson. These are 2 examples of the same area, which was, as you can see here, surveyed with a different electrode separation, so 0.5 meter and 1 meter, and you can see that the results are different. This is then the interpretation of all that, with again lots of useful archaeological information. But now the question is, why are we using those different electrode separations? So if we increase that separation between the electrodes, that means that we will measure objects at a greater depth. Again, it's perhaps a little bit more complicated than that if you really go into the physics, but that's what it comes down to. We will also be able to reach deeper objects. So here again, right to the image of the instrument. That's what we also did at Ammaia. Another example shows more or less the same. This is work by Jeroen Verhegen, also from the department at Ghent University. And he also did this kind of survey with 2 different electrode separations, so 0.5 meter and 1 meter of the forum area. And again, you can see that there is a difference in the results. So that can be useful because we can know more if we have 2 different data sets. Summarizing for earth resistance, again, this can see different things. I wrote here stone foundations or foundations and ditches, but there's a lot more. Biggest drawback or disadvantage is that it is slow. And for that reason, again, there have been more recently, we weren't able to use them at Ammaia, but there have been much more efficient and quick systems developed. This one here was originally developed by Michel, who is also in the audience and part of the Auroch laboratoire. Now it is used for doing very large surveys. Here are a few archaeological examples of Roman towns. So this is not Ammaia, but these are examples from France, where you can see how much information there is in this kind of images. Other example here from Epomanduodurum, where again you see all the information that is in there. Now that was it for the 3 different techniques. So we had magnetometry, earth resistance, and georadar or GPR survey. And as you can probably see here, it is useful to combine all those data because they are different. Each of them here, again, at the forum area in Ammaia shows really something different. So we should try, if we can, to do measurements with each of them and combine and compare those data. going one step further is not to just look at the images one next to the other, but is to really try and combine the data into a single image. That's what I tried here for a different Roman city in Italy, but the principle is the same. So we have magnetometry and georadar, and we put that into one single image. Here in this case, by simply making the magnetometry a little bit transparent. But like this, you can see much better the relationship between what is in the magnetometry and what is in the georadar. But this was also done at Ammaia, again by Jeroen. He did many different tests with combining different data sets. For example, he subtracted magnetometry from resistance, or he added the two data sets, or he did more complex operations, which each time show a slightly different picture. So it's really worth to do all those tests. Other things you can do is to put or to construct a color image. You will all know probably that a color image consists of three bands, so red, green, and blue. And you could, to each of those color bands, you could attribute a geophysical data set. And applying that here, for example, you see that in green and in blue, you see that the walls are caused mainly by the resistance data sets in the two electrode separations, whereas the mag in red is more the background soil, you could say. Same here. Here we include also the georadar. And again, the purple color here, purple is red and blue, so you could say it's mainly caused by the resistance and by the georadar, the wall foundations, whereas the rest is more caused by the magnetometry in green. Then a later step, or an even later step in the process of treating the data is of course to interpret them. And in order to interpret them, as I already showed, we have to make these manual drawings. We can do that in 2D or in 3D in the case of georadar. But of course, that's a lot of work for a very large site that can take weeks or months even to make such a detailed drawing. So what people have started to experiment with in recent years is if we could not let the computer play a more important role in this drawing. And this is one experiment, again, not from Ammaia, but it could be applied to Ammaia, and where you see that the computer extract the wall information and the floor information in 2 dimensions and also in 3 dimensions. This is still very complex. It's still in its infancy, you could say. It's not yet ready for routine use on very large sites, but that is what could be the future in a few years. One powerful tool to do the same thing, so to make the computer do part of the job, is what is called neural networks. So those are based on our own brain, our own human brain system, or our own human neural network. And like this, the computer can make a segmentation of an image. So that means that of each pixel, it will tell whether it's a car or a building or anything else. So this is what it could like for an archaeological example. This is not really the result of a test with a neural network. It's just to give you an idea what it could look like. Because what could happen, of course, is that the computer doesn't detect everything in the right way. It can forget to detect things. And then it is important to stress that also the human interpreter will still have to play a role. And the human interpreter can then, for example, indicate that this also belongs to the interesting data, from which then the computer could update its data and learn so that it can next time make a better segmentation. Last thing I would like to show you is the 3D visualization. Davy has already shown a few examples also. Here we should make a clear distinction between this and between 3D drawings I already showed before, like this one, for example. This is based only on what is really in the ground, on what we have been able to observe. There is a difference here because, for example, we don't know exactly what the windows or what the roof looked like. So it's not all based on observed data, but still, this is very important for us to be able to imagine what the town may have looked like. And there's a few examples of the temple, for example, already shown, and of the inside of the basilica building, which is this one, for example. And again, the view of the whole city to end this presentation. I had prepared a film also. It's about 7 minutes, but I don't know if I should show it now. Perhaps you can all, if the presentation will be on the internet, you can all check the link here and look at it when you have time. And so that was it for my part. And of course, we are open to all your questions. Thank you.